The following presentation is for Nexio's BAT-EMC software version 3.20. In this example, we're going to explore the automotive with bands test as well as the CISPR 25 hybrid test for the new Annex I5. My name is Greg Garza and I am the presenter. First off, let's explore some of the background about Nexio. Nexio was started in 2003. And BAT-EMC software itself was created in 1995 by the founders. Ever since 2003, indeed, electromagnetism is our thing. The two primary areas of focus are the interferences and the propagation. Since 2010, Nexio put a lot of energy into an internal research and development department and developed a number of new modules and test capabilities. And we have a strong presence internationally in Europe, the United Kingdom, the USA, Canada, Australia, Latin America, and Asia. In this slide you can see some of our products and software, primarily the BAT-EMC software, benchtop automated testing for EMC, that you are already familiar with, and then things like the lab management software, the BAT scanner, for near-field scanning, and then our simulation software for things like electromagnetic antenna patterns and radar cross-sections. In this slide you can see that we have a number of engineering services we offer as well, and the point here is that the entire company of Nexio is solely focused on EMC. This shows a snapshot of some of our major modules. Besides the ordinary radiated and conducted emissions and immunity, we are also what I believe to be the industry leader in the reverberation software. I've examined the competition and they are definitely missing some points and have shortcomings. We also have our module for the various electrical tests such as electrical fast transients, burst, surge, and so on. The other modules to mention may be the radiation patterns or things for the NSA and SVSWR. But keep in mind though, and this may be my opinion, our monitoring is the most extensive of any software out there. Especially compared to the competition. We lead in that role, and this is probably the reason why the biggies in automotive, GM, Ford, and Chrysler went with our software, is because of the fact that their monitoring and fault reporting capabilities were needed and much more extensive than what was available by the competition. So we excel in that area. Not to mention, especially for GM, they had extensive custom report requirements. Just a quick slide to show that we have a strong presence internationally with a number of sites in a number of countries, a large number of sales reps, and we have the major countries listed here. This describes our team. We have the sales team plus our sales reps mentioned above. The important point here is that we have a separate development team from our support team. If the support team, for example, was busy with customer support and issues, how could they possibly be focused on development? Likewise, if the development team was bogged down by customer support, how could they possibly be focused on development? So in this way, each department can stay focused on their primary roles, but of course in times of great need, if the support team needed to, we could always leverage assistance from the development department. Okay, now I can describe a little bit about the automotive with bands. It is a specific module for the emissions test in accordance with the automotive standards. This includes the OEM specific standards such as for Ford or Chrysler. We have a new limit editor, which I will show you. We have a test creation assistant or wizard, a new execution interface, and a new customized report generator. So we have a limits by band including receiver settings, unlike the previous limits which were just a limit not to exceed. And this I will show in the next slides. With the test creation, it is much faster because of the wizard or the assistant. And we have other possibilities for speeding up the test. One, for example, is the peak detector instead of quasi-peak. If we use the peak detector, it is much faster. And then the software has the intelligence built in to go back and remeasure any of the peaks that were to overshoot the limit. Same goes for the ability to measure with the resolution bandwidth of 120 kHz instead of 9. It would be much faster because it's a wider RBW, but of course the noise floor could be higher, so there may be instances where the peaks are pushed over the limit, in which case those could also be remeasured on a case-by-case basis. The idea is one scan for a frequency band with overlapping limits if settings are identical. That allows for a number of them to be tested sequentially. And then we can also test with multiple limits. This is an extract from CISPR 25. On the left, the limits are shown with all the different detectors and the bands, the frequency ranges, and what the limits are. On the right-hand side are the associated settings that would be used for measuring those individual bands. So imagine that we captured the requirements for the limits and the requirements for the settings, and we created a test capability based on that. This I will demonstrate. So, looking at the software, I have a completed test here shown for this project. This one was one that had finished data. This is simply one that's duplicated and hasn't been run. And you can see that I have all the bands. And in this case, we're looking at CISPR 25, Table 7, Class 1. So let's explore that limit. If we go to the emission resources, we have a new section called Limits for the Automotive with Bands. So keep in mind that just as before, Nexio personnel create these limits. We provide these limits to you, but we also train how to create your own limits as well as to edit the existing ones. Table 7 Class 1 was the one I mentioned, and you will note that all the bands, like we were looking at before from the standard, are listed sequentially. You can also note that not only are the limits for those emissions for the different detectors captured, but also the settings required. An additional feature is shown above because we have two more boxes, define measurement time and define frequency step. This is not required, but by doing so, it's a time saver because whatever you enter here for those measurement times and the frequency steps will be used as default later, and then when the test configuration window appears, you can of course edit those if you needed to change them later. Now back to the project. And what I will do is simply create a new test from the very beginning. So I can right click on that, create a new test, Automotive with Bands. I will give it a name. I'll just call it CISPR 25 new, and then I will use the assistant. You could also do it without assistance and build things individually and manually just like you were able to do before, but there's great power in using the wizard. I click on that and then all the available limits are shown so that we can choose them. Let's see, if I expand that, I can choose the one I was referring to before, Table 7, Class 1. That would be a good one for this example. Now you can see all the individual bands listed. and you could select or deselect the ones you didn't want to use, but the idea is, for efficiency's sake, to test as many as you possibly can with the resources that you already have. So at this stage, we need to associate these individual bands that we selected with equipment setups. And you can see in red that we were given a warning or a request. And so I happen to know the equipment I wanted to use for this. It was a set of setups using the N9038 receiver with a number of antennas to cover those ranges. So as you can see, none of these are covered right now, and as I choose my setups for these frequency ranges, when I click on that, that one is shown as covered, and so on and so on, so that now I no longer have any uncovered bands. They are all able to be tested by those chosen equipment setups. I can click on Next, and you can see in this test configuration window all of the information is captured, yet I also have some additional capabilities here. Let's say I wanted to edit some settings for that particular test. I could click on that and I could edit anything I needed to edit there. Another option would be, I'll show by example, I'll click on that band and I'll use Shift to highlight a section of them, and then when I click on the edit button, it will be a global edit for all of those bands. A nice feature to have. Here in the center column, it states measure peak instead of quasi-peak. Yes, we want to do so. That is a much improved time saver. You can also choose, let's say this is the CB band. For anything that goes over, I will request it to be remeasured, and furthermore, I can use a larger bandwidth to make that faster. So for this band, I chose it to do an auto remeasurement as well as use the larger bandwidth. I'm not going to do that for these other bands because then I can show how that could be done manually later. All of the individual bands are shown. You can verify that all these bands are listed sequentially. This would be another time to do any edits. For example, if you needed to change anything regarding detectors or number of sweeps, attenuation and what have you. That could have been done individually, or as I showed before, globally for a section of bands. I will simply accept what I have here, click on Open, and then this window will launch. It launched off screen, so now I'm arranging it here, and you can see that I am ready to execute this test. I could set the button here and start for all of these. I could choose individual ones I want to run. I could choose groups of them based on the setup, based on the polarity. Now, over here you can see the limits for that band and so on. And this is the sequence we're going to follow. Let's go ahead and execute this test. And the resources are shown here on the block diagram as before. I will select OK. And let's just follow the prompts. While it continues to test in simulation mode, you can see that the status changes during the test over here in the execution window. And then over here you have the ability to view the different tests down below, while up above the current test is being run. So current test in progress above, whatever test you'd like to look at below. And you can see here that we have conclusions for those individual bands, as the tests are being run. I will simply click OK, but keep in mind, just as before, if there were any other additional options in the resources, it could be chosen there. Another good thing to mention while this test is running is that all of these colors and the backgrounds can be customized. The limits, the curves, the cursors and markers, all of this can be customized, and not only for what you view on screen, but whatever goes out to the saved file or printer. I'm just following the prompts, and we are almost done with this test. Another thing to show is the ability to edit access settings. The settings could be done to be logarithmic or linear. The high and low points can be chosen. The scale could also be done automatically. So there's similar abilities to before, but I think they're more enhanced. Now, as you can see, this test has been run, and we have all these different bands that we could view the data for, as well as the results. If I slide this down, let's see if there's anything with more results. I guess not. Okay. Now, earlier, as you may recall, I asked for an automatic overshoot for one of those particular bands. But let's say I'll just click on this one, for example. I don't have anything that's failing at the moment. But let's say I wanted to remeasure this one manually. What could I do? I could select additional measurement, and then I can use my shift click over here. Now with that area highlighted, I'm going to remeasure that area. I could have also manually put in a start and stop frequency. Next, I have the ability to do a manual measurement and control my own settings. And if I don't want to control my own settings, I have some pre-configured settings right here to make it more convenient. And that's what I will use. I will say I'm going to remeasure that with the quasi-peak detector. So let's do so. The dialog window appears. Everything looks good. Everything looks good on the resources still. That's the right polarity, and now it has been tested again. You can see here the original curves in blue and green, and then the quasi-peak curve that was added, and you can see it here in the legend that it reflects this new measurement. Okay, let's close this test. Now that the test is complete, it shows the results tab right off the bat. This is what would normally be chosen prior to the test, but when it's completed, it conveniently goes to this page. Now let's print a report. You can right click on it, but now there's only the new version available for these. Let me find the report templates. All these templates are provided with the new setups, and they can be found in the folder that's created under BAT-EMC. This is going to be an EMI by band, radiated emissions, and now I can give it a name. I will call it Auto with Bands New, just to give it a name. And I could go get a cup of coffee or something like before, but it's just too fast now. It completes in just a few seconds, so once complete, we can view the report. And as I scroll down, you can see we have a summary, we have the details in the tabular view, as well as all of the individual graphic images with the legends. If I were to expand out, you can see that this is quite an extensive report that was done in just a blink of an eye. So there's a huge time-saving capabilities in the testing portion as well as the reporting portion of this. Okay, so one other thing I could show you is that besides the creation like I did before, it would also be possible to do a duplication. Let's say you were doing a number of iterations in a troubleshooting mode and you were doing things like maybe adding ferrites or adding shielded cables, and I can just call this run 2, and then all I have to do is say OK, right click on this, then I can delete all the data. You can see that the conclusion is now changed because I removed the existing data, and I could just open it up again and run it. So there are a couple of options here: creating one from scratch using the wizard, or using the existing ones and just duplicating them. The next thing to demonstrate would be a rather tricky item for General Motors testing. Let's open up that project. And each one of the major manufacturers has the majority of their testing based on the CISPR 25 standard with their own spins on it. And for the GM requirement, they have these different orientations, and there's a requirement for reporting the worst case for each individual orientation, then to determine the worst case for all three. So how do we do that? Right click right here, add analytic report. I will give it a name, and I will call it GM worst case, for example. Then I can select the limit. If I were to expand, let's go to this GM limit here, for example. That was the one used for the tests. Then I can add the tests that I want to do the analytic report for. I will use these three orientations for now. Select OK. So now I have these three chosen. When I select OK, it will launch. There's a lot of data in those individual orientations, so it requires to load it and then to do the comparisons. So let's look at some of these. In this case, we're on the top one, orientation 3. So if I click on individual ones, orientation 2, orientation 2, go to different ones randomly. Yeah, so we have some that were a different orientation as the worst case than the others. So once this is done, I can close it, and we can generate a report based on it. Go back to my report templates. Here we have the ones specifically for GM. I will give it a name. How about if I call it GM worst case? So it wasn't exactly the blink of an eye, but when you look at the amount of data it had to go through, when you think about that, then it's understandable. So there we have it. The conclusions as well as the worst cases are shown. Now we can explore the CISPR 25 testing for the hybrids. First off, let's describe the requirement. In the new section, Annex I, Section I.5, we have a requirement for measuring the coupling between the high voltage and the low voltage systems. Section 5.2 is based on the measurements defined in Clause 6, and then 5.3 is for the attenuation for the coupling. There are two phases to this. The first is the signal injection and calibration stage. That is done on the high voltage sides. We also have the stage for measuring the emissions. That would be done in 3 different ways: using an artificial mains network, or listen, for the conducted portion, conducted voltage. The current is measured through a current probe, and that would be very similar to the voltage test. And then we have the radiated emissions test in free space, and still in either case the methods are all quite similar. In this example, we are going to explore the conducted voltage. So let's explore the calibration first. This is an extract from the standard, and you can see that there are 2 methods, the one according to the ISO standard or to the DCC. This describes the range from 150 kHz to 108 MHz, peak or average, with the RBW of 9 kHz. We use the average level from the table I1 as the target, and it's to be done both on the plus and minus sides of the high voltage lines. In orange, you can see the injection path. Blue, you can see the measurement path. And there you have it for the calibration. We are using the modules we have for immunity that are also used for things like the module we have for BAT-FT, which is for obtaining transfer functions. That's simply a matter of injecting a signal and measuring the emissions. For example, when sweeping a cable, you would inject a signal at one end, and then you would measure at the other, and when it's swept across the range, you would measure the loss, and that's how you characterize the cable. Well, it's very similar here. Regarding the emission measurement, we have the injection path as shown. We also have here in red the measurement path. And just a note to say that it's basically identical between the other 2 methods. Now, let's go ahead and explore the software here a bit. And I need to open a CISPR. Yes, exactly. The CISPR hybrid project I already started. And I already started it, and I already ran a few tests. But still, I can show a new test here in simulation. The calibrations were done up here above. Let's explore that a little bit. This was just a partial calibration to get things rolling. To do so, it would have to have been done on these individual frequency ranges as well as the plus and minus side. This was just the plus. And if we look at one of these tests, let's look at this test for example. You can see there's only one subrange listed here. It would have had to have been done for both the plus and minus side of low voltage. If I expand the subrange area, we can look at the procedure used. The frequencies tab is basically identical to an ordinary test. Then we have something that looks very similar to an immunity test because it mentions the method, it mentions the regulation level, which would be the one shown here in the calibration. CISPR 25 class 1 HV+, that's this one here. And then the required level, which is from the actual limits. As far as the emissions parameters are concerned, same sort of concept. We have a limit, the detector, various receiver settings, and then the test can be performed. So rather than viewing the previous data, let's just go ahead and duplicate this one, and I will call it run 2, for example. Should be run 3, that would be better. Now I will execute it. And we have one window that appears on the main screen here. The other one's on the other screen. It's difficult to show two screens, so I will just drag them over. Ask if I want to execute it. Stay in simulation mode, of course. The block diagram appears as normal to verify the resources. It asks if this is phase 1. Yes. And I can drag this over to show that the test is being executed. We have the frequencies being shown there, and then on the monitoring window you can see the status. You can also see that the tools were activated. So we have a completed test. I can end this test. And there you go. We have a completed test. As I mentioned before, it was using a monitoring window. This is something we configure with you. Another thing to mention is under the immunity resources, all of these control tools, such as for the test we just ran, would be configured here. So we provide all of these control tools and assist with the setup and validation for all of these tests. Let's go back and explore another aspect. That would be the coupling attenuation. Here I have a test. It's shown as being completed. That's just fine. Let's view that data. Appeared off screen. According to the legend here, the green line is the S21, and then the limit is shown in red. So there you have it. A completed test. So at this point, keep in mind that we have additional videos to publish as well. They will be made available alongside of this one. I have a video I created specifically for Ford along these same lines. I also have one specifically for the report generator for GM. So keep paying attention to the videos that we offer and the webinars we offer, because there's a lot of great information coming your way. Thanks for your attention.